Hey, I thought I'd give you a little bit of help on the Chapter 6 review. Try not to give you answers, just give you some ideas on how to proceed. So here you see, first of all, they list the postulates and theorems that you're going to need to be able to do for that test on memorization. Quite a long list here. Brush up on those, make sure you're ready. Also, remember there are two constructions that you're going to need to be responsible for on the test. So they start out with a review of symmetry, line symmetry. We try to remember the best way to determine line symmetry. A line has something to do with folding. 4 of these flags are pictured. One of them doesn't have line symmetry. Look carefully. Should be able to find that out. And for the others, you're supposed to draw in the lines of symmetry. So here we've got points A and B. You're supposed to do those on your paper. And it says use a straight edge and compass to construct a line such that A and B are symmetric with respect to it. Now, if you think back to what that meant, symmetric, it means they're the same distance from it. So what would the construction be? Now, this will help remind you. So what did we just construct there? Yes, you are correct if you said the perpendicular bisector. That kind of gives you the answer to number 5 as well. Bird's eye view, helicopter view, what is it? That's all they're asking in number 6. Arrows kind of help you. If you're a driver, you might be more likely to get it. What they're going to ask you to do is to construct this. And they ask you, how did they do that? And maybe these little arcs right here kind of help you. So if you were to just take these 2 arcs and think about this line, whoa, sorry about that, and this line. And you notice they've got a T here, think transversal. So does that give you an idea how you would construct this? So draw a line to show the transversal. There it is. And then we're going to try to, well, we're going to get A, B, and C and D equally spaced. So just stretch out your compass to an appropriate length and mark those off and label them A, B, C, and D. And now you'll notice right here they want a 60-degree angle without using your protractor. Well, think for just a minute. What kind of triangle has 60-degree angles in it? So maybe you'll be able to think that one through. Hint is start with your compass right here on the end. If you haven't changed it when you made this original arc, you're going to be in business. And you're going to move over here. That arc. So what kind of triangle did we just create here? If that and that and that are the same, right, an equilateral triangle. So if you're drawing one of those, you've created right here the 60-degree angle that they asked for. So you got to repeat that to get the rest of this. Okay, we're going to use the shapes of the letters of the alphabet in this next part to remind you of the definitions and theorems as you get ready for the test. So there are some suggested here by the letters. You're going to have to look through. They actually started for you. An exterior angle of a triangle is equal, and then you finish that. So you get the idea, the picture, and then the start of the theorem or definition. Work through those. Good review. Okay, we're looking at Ollie. He's also getting ready for the test. He misstated 4 theorems. Alice, the ever helpful Alice, decided to try to help him out with some drawings to help him figure it out. You rewrite it. So before you look, see if you can figure out what he did wrong, what he left out, how he did it incorrectly. So the first one, in a plane, a point equidistant from the endpoints of a line segment determines the perpendicular bisector of the line segment. Sounds similar. But here they have one point that's equidistant. And you can see that is clearly not the perpendicular bisector. How do you misword that? Here's another one. If two angles and a side of one triangle, two angles, you see them here, two angles and a side of one triangle are equal to two angles, there they are, two angles, and a side of another triangle, the triangles are congruent. They're clearly not congruent, even though the angles and sides are right. So there's a mistake there. Find that and fix it. Is it true that if two sides of one triangle are equal to two sides of another triangle, the third sides are equal? Well, here you can see two sides here. Here you see the same two sides over here. And all they did was slung this one out a little further before they connected it. And clearly those triangles are not congruent. What's the mistake there? A line perpendicular to one of two parallel lines is also perpendicular to the other. That sounds very familiar. But here we see a line perpendicular to one of two parallel lines, and it's obviously not perpendicular to this one. It doesn't even intersect it. So there's something missing up here that makes that statement incorrect. All right, keep track in the given here. These are equilateral triangles, these next several, divided into 5 triangular pieces. You can see them here, 1, 2, 3, 4, 5. Make a copy on your paper and write in all of the other angles. It's important to remember that it's equilateral. And what's true about an equilateral triangle? Since we're trying to find angles. Right, and you can see it right here. This angle on the top is 60. Use that idea. Here's another one, same idea. Triangle angle sum theorem comes into play here. Here's a third one, and now they ask you a few questions about these 3 triangles that you've done. What do all of the triangular pieces in all 3 figures have in common? So if you look at all of the triangles in this one, all of the triangles in this one, and all of the triangles in this one, they have something in common. It's worded kind of strangely. See what you come up with. How many are equilateral triangles? You may not have the same answer in each one. So you are going to need 3 different answers here. Okay, you cannot trisect every angle with just a straight edge and compass of construction. But a right triangle you can, or a right angle I should say, and they walk you through the process here. So go ahead and do that. Follow their steps, step by step here. So now if you use your protractor as they suggest right down here at the bottom, what should each of these angles be? This one, this one, this one. If you trisected a right angle, yes, they should be 30. Now they want you to draw those 2 segments in there. And they're asking about this triangle and that triangle. Back that up. What kind of triangles are they? Remember, you can classify them by sides or by angles, sometimes by both. Just looking at those 2. Then they're asking actually about the angles DAB, so it would be this one here in the pink, and EAC, this one in the blue. A couple things you might be able to say about those. How about angle EAB? EAB, just this small one down here. Remember, it was a trisection problem. And a cartoon you can look through for yourself. Something to do with road work and the sun and so on. Okay, so they've got 2 surveyor's triangles here. They're right triangles and they're deformed. The heat got to them or something. because if they were just right, there'd be a straight line up here where the two met. But they're defective, and when they do that, it looks like M is perpendicular to line L down here, and N is perpendicular to line L down here. So you've got two lines perpendicular to this point, and the question here is about that idea. How many lines can be drawn perpendicular to a given line? And then state the theorem that works. Finally, this one's worded slightly strangely, but what relation would the line that is actually perpendicular to L at P have to the angle shown in red? So here's line L, and since neither of these lines actually is perpendicular, if we were to draw the actual perpendicular line in up here, they're asking you what relation would that have to the angle, to angle M, P, N. And that's not actually right, it's just angle P. Those are the names of the lines. Shouldn't have used them there, but I did. So they're asking for the relationship of that line to angle P. Okay, next, draw line L. Put a P on it, and then construct a line through P that's perpendicular to L. So we'll walk you through that again. Start there. Do two arcs. Don't change your compass in between. Go to one of them. Do the big arc. Sometimes we only do this much of it, from there to there, and from there to there. Then move your compass over to the other side. Do the same thing again. All you really need is where it intersects the first arc, there and there. And we draw that line, and that's perpendicular. So it's a review of constructing the perpendicular. That'll be on the test. Okay, magnifying glass, the thing that melted the ant, or fried the ant on the previous set of problems. You can take sun rays, maybe you've done this before, focus it down and start a little fire on a piece of paper. So some givens, these little arrows again mean, yes, that they're parallel to CP, or I'm sorry, to BF. And this is important, CP is the perpendicular bisector of BF. So not only are these parallel, CP is the perpendicular bisector. So we could draw this mark and these two marks. So keep that in mind as we move on here. And some questions about it. Take your time, look through those. Again, it's referencing theorems from the chapter. This one flashes back a little bit. We've got these three segments meeting at one point. What's the word for that? Congruence. Congruence of two triangles. These two down here. BDP and FBP. These two triangles right here. So why are they congruent? And then following a congruence statement. Why are the angles equal? And then what can you say about angle ABP and EFP? Remember, we just made those two triangles congruent, and we know that those are perpendicular. All right, this one harks back to when Alice was measuring the distance across a creek. A little bit different here, though. So we find a point C directly opposite the tree, so we're across the creek. So you're walking, find a point C here using some device that helps you measure to make sure that you've got a 45-degree angle right in here, 45 degrees. So you want that to be 45. We then lay off from C a line CD that's perpendicular. So we want this to be perpendicular to AC, that path across the river. So it's actually going way over here, perpendicular. And then you walk along here until you make this angle right here, 45 degrees. Okay, so think about triangle angle sum when you're doing this. Think about the acute angles of a right triangle. You see we've got two right triangles. CAB is a right triangle and ACD is a right triangle. Keep those ideas in mind as you answer these questions about angle B and CAD, the segments, Y, and then finally, why is CD the exact same as the height of the tree, which is what we were trying to figure out. The height of a tree over a creek. Why are those two the same? All right, we've got a quadrilateral here. This is actually a preview of the next chapter a little bit. And you see the markings here. AD equals CB, and these two sides are parallel. Those are givens. Keep those in mind. Find some angles that must be supplementary. Okay, remember, these are the parallels. Some angles that have to be supplementary. How do you know that? Again, review of the theorem. Do you know that any of the angles are equal? If so, which ones? Okay, think about that one a little bit. Any of the angles are equal. Here we have an isosceles triangle with a bunch of things equal. A, B, I think I marked them. There they are. I marked all those equal. Before we even start the problem, what can you tell me about triangle CDE? Looking at the markings. Oh, DCB. Oh, and also CBA. Looking at the markings. So they want you to draw it, mark it up, and then find angle X. And don't do the blonde thing. When asked to find angle X, and she went like this and said, here it is, here it, oh, I can't spell that very well with my mouse. Here it is, thinking, hey, I found it. Obviously, they want you to find the measure of angle X. So ECD, I'm sorry, not find the measure actually, but you're finding the other ones in terms of X. So ECD, CDB, CDB, this one up here, DBC, that one, AC, and so on, all the way around. And then finally, write an equation and solve for X to find the measure of angle E. So yes, finally you can find the measure of this. Think about it, you'll come up with it. Okay, we've got some stair steps. Again, what's important? The givens. We've got right triangles, so we know this to be true. And we know some sides are equal. Well, that would make sense. Every set of steps, you want to have the same height up. That would be hard to walk up and down. And we also know that C is the midpoint. Well, that would also make sense because they would want to keep these the same. So C right here is the midpoint. Copy it, mark it up, and explain why is BC parallel to DE. Remember, when you're talking parallels, you need a transversal. So my suggestion to you is think of EA as the transversal. And now explain why those two are parallel. This is what we're after. Why are those two parallel? SAT problem. 3 angles formed by parallel lines M and N and a transversal. There you see them. There's a 40, angle Q and angle P. Problem is pretty simple. Or I mean, it's a one question. Find P minus Q. Be careful with this, all right? It's not hard, just be careful. Explain how you can find out the difference between P and Q, P minus Q. Obviously, you're going to have to find numbers for those first, and then subtract them to find them. So there's your help on the chapter review. Hope it is that. Work hard and see how you do.